Hello, and welcome to Procedural Modeling and Tool Building with Houdini. This course is going to go over the fundamentals of building tools using procedural modeling techniques, primarily geared towards hard surface modeling in Houdini. The tools that I build are primarily focused on large-scale world building and architectural replication, architectural prop creation, and getting those to kind of fit into a larger whole. So this course will primarily be focused on learning how to model those kinds of things, build those systems at large. But we will have in there some, other ways of looking at organic things and things along those lines. What this course will not focus on is any kind of character work or anything along those kinds of lines. This course will take you all the way through from building tools in Houdini that we can use in Unreal Engine or Unity or Maya, but we're going to specifically be looking at how we can use these tools to harness the power of Houdini and build large-scale open worlds geared towards the real-time development world. And by this I mean Unity and Unreal. Before we actually get started building any actual tools or anything along those kind of lines, I want us to understand some of the fundamental choices that we kind of have to make at the beginning when we're deciding to build out tools. And I've seen a lot of tutorials out there on procedural world building and tool development, procedural modeling in Houdini. And a lot of them are primarily focused on polygonal creation and things along these kinds of lines. And I want us to take a look at both using polygonal surfaces and NURB surfaces before we actually get started so that we can kind of understand the differences between the two and how we might harness the power of one over the other sometimes. NURBS modeling is not something that you see a lot out there anymore. Most people are focused a lot on polygonal modeling, but we do get some benefits with Houdini, with NURBS modeling. And this is kind of what I want to take a look at when we're beginning to decide how we're going to design our tools, right? So let's just create a geo container. Right? We don't need to even name it at this point. And let's dive in and let's look at a very simple example, right? So I'm going to just create a circle. And I'm going to make sure that my circle is going to be oriented on the ZX plane, right? Like that. And then I'm going to add a poly extrude. And we can just simply wire our poly extrude in, hit the enter in the viewport, and now we can drag out up or down our object. The first thing that we notice that when we make a circle and we orient it to the ZX plane, it's reversed. So when we make our surface, it's coming out reversed, hence we get that gray surface. We're not making the bottom of it, we are making the top of it. And the inside surface is the surface that's being shaded correctly. So this just really can be fixed by coming in here and adding a reverse node here in between the two. So you can see it changes the color of the circle. And now when we poly extrude, it's going in a negative direction, right? So that's why it's reversing. That's from before. So now we can put it in a positive direction. By and large, we're going to want to have positive numbers when we use poly extrudes. We don't always have to have that, but it can be beneficial. We can always fix it with a reverse, but it's kind of good habit just to get in the habit because we don't always want to have negative numbers in here. So the first thing is that if we were to imagine that we were to start building out some kind of pole or some kind of horizontal structure, that we could just simply use distance and we can build a tool that will easily be able to alter those things for us, right? And currently, the poly extrude is not making the bottom, which we want. So back on the poly extrude, I'm going to close this side off. This is my custom desktop for Houdini Digital Assets. I'm assuming that most people that are going to be taking this course are going to be familiar enough with the Houdini interface that I don't go into interfacing at all in this tutorial. So you should be comfortable using the interface, knowing how to make desktops etc. This is one that I use for creating Houdini digital assets because it allows me to kind of go between both worlds. And they're not linked up because up here I have no link on. And I also, I like to have my grid lines on. So we can see I've got that grid line options. They're pretty faint in there, but it's just something that I can snap to. I went to architecture school. The grid is pounded into your head. So I'm used to using a grid and laying things out on a grid. Okay, so let's fix all of our little minor problems. I'm going to just close that bottom here by clicking Output Back on. And now I want to do some procedural work on here that we can have access to. Well, we have access to the groups in Houdini, so we can simply just go front group, and that will allow me to have this extruded front here, right? And then I could add in a poly extrude like this. Okay, and I'm going to extrude that front group up here by selecting it here. And now I'm going to add a an exterior inset like this, right? And we're getting some Z fighting. That's just because we need another one. So I'm using the group to inset, and we have no option here to get a negative number. I'll show you what we do when we need to roll that into a tool. But then I will add another poly extrude here, like this. And I will set it back to extrude front. And now we can extrude a height like this, right? And you can kind of see where I'm going here. I could add another inset, right? So I'd add another poly extrude, right? Another poly extrude like this. And again, we'll just grab that extrude front group, right? And I will add an inset like this. And really, we want that to be the reverse of this. So what we could do is we could just do this for now. This is kind of copy parameter here, and we could do a paste relative reference, but then I could actually just minus that and get a positive number because two negatives make a positive. And then we could make another poly extrude, right? Like this. And I'm going to, again, choose that extrude front group and extrude it by a distance. And now we have something that's fairly procedural, right? Like we can come back here to our poly extrude, and we can change the distance, right? So using the ladder going up and down, right? If we want to change our inset, we could do that by going like that, so we can figure out how big that we want that. We can make it however big we want. And we can control our resolution. Let me just turn on, hit smooth wire shaded, right? And if we wanted to, we could make a group node so that we could procedurally select all the angles that are at 90 degrees. So we could add a group node like this. And automatically, we want to disable our main group, and we also want to set our group type to edges, and then we can just come down here and it uses include by edges. I use this all the time for being able to grab edges procedurally, and with clicking that enabled, once we click that, we're going to get our correct edges. Now, that works automatically, but it also can cause us some problems potentially down the line, right? And so what I'll usually do is I'll go like 88 and 91 or something like that, and we'll get the same thing, but we'll ensure that other things, maybe something that's, you know, angled at 12 degrees or something like that doesn't or it doesn't get picked up, you know. So I always also, just as a side note here, you can see here in my group name, I'm using an expression up here. It's op name. If I Alt E and tag and make that bigger, you can see it's just op name, operator name, right? So it's a backtick backtick up there. So that's the one above the tab and below the escape. It says op name, OPNAME, parentheses, quotation, period, quotation, end parentheses. And it's an expression I use all the time. It just simply means operator name, name me what my operator name is. So group one in this particular case. So you can see we have a group called group one. And so what we can do is we can just call this whatever we want. And this brings up another kind of little thing that we should talk about when we're going to be considering procedural modeling is, you know, when we do use groups. And I try to kind of come up with some conventions that will carry through on all of my work, right? So edge bev is a name that I use for edges that are going to get beveled that are in a group, right? And if I have multiple versions of them, I'll just have edge bev 1, edge bev 2, edge bev 3, etc. And it would allow us to proceduralize certain things down the line if we want. Like, for instance, I could come in here and I could add a poly bevel now, right? So poly bevel, and come in here and select that edge bev 1, right? You can see our selection has turned green, and I can add in a distance like that and add in a bunch of divisions or something along those kinds of lines. And so now, but I want to also show that imagine if, you know, if we had a bunch of things that were coming in that we were all going to bevel exactly the same potentially, and we would have, you know, maybe several different groups, edge bev 1, edge bev 2, edge bev 3, etc. What we can simply do in Houdini is come here and do edge bev and do a star, and no matter anything that's coming in now named edge bev will get beveled. Right? So we can proceduralize groupings this way. So this is a Unix wildcard. We'll be talking about those throughout this course, right? But we can use them all the time for various things, for helping us while we're proceduralizing and looking at our naming conventions, etc. So I do suggest coming up with a good strategy for naming for your group creation. I do suggest using that op name because it's very easy. If I just was to drag that off, we have a nice procedural thing that we can grab any point down the line, right? So just something to take note of. Okay, so we've got our poly bevel, you know, and I'm just going to add a switch in here like this, and that way we can make poly beveling an option or not, right? Boom, option or not. And in this particular case, let's just add a UV unwrap. Right, so we have UVs now. We've got these groups lying around too. We've got that extrude front group and that edge bev group. Now we don't need that edge bev group anymore, and we don't need that extrude group anymore because we're at the end of our chain here. If we wanted to do something with the extrude group, we would have to come back up here, which we probably will do because I want to show a few things still. And we will, but when we get down here, right, we've unwrapped our UVs, these groups are lying around, we no longer need those, and it's a good habit to get rid of them, right? So I'm just going to hit spacebar 5, take a look at my UVs. Let me get rid of that UV background that I've got lying around, and we can see we've got our UVs, and we can do a UV layout. Now, honestly, I'll often put this on a switch as well. That way, like, I'm not slowed down while I'm working if there's heavy modeling. And I usually also like to label these. So we could call this a switch beveling, and we could call this one like switch UV layout, just so we know what it does. Someone wants to come back in our file. I usually like to change my noodle styles, like these lines. So I'm going to hit Shift S and kind of change them to this. And I'm going to do a little bit of cleanup by selecting all of these, holding down the A key, and like dragging up to just kind of clean up my nodes, right? Like I said, I went to architecture school. I like things to snap onto the grid. Okay, so So fundamentally, we've got this like really simple little tool, right? If I come here and split my window two ways, right, we can look at the UVs over here, and we could come here and I could be, making them taller. The UVs are getting rebuilt, right? We can adjust our insets, and everything is getting re-UV'd correctly. Now, here comes the kind of issue, like what happens when I want to attach something right here, right? Like maybe I want to have an arm that comes out from there. How could we do that? I mean, conceptually we could, right? Because we know here that if we have this height amount, which is the first height, right, then we could, conceptually we could add a point, right, put it here, right, and we could make it the radius of the circle, and divided by 2, right, and then we could maybe add in another value that would push it down a little bit by a certain amount, and we could have an arm that would come out, right? And that's one way of handling it. But then when we start having to potentially do that, like let's say I want to add in nuts and bolts along this top edge, right? How would we necessarily do that here, right? That becomes a little bit trickier of an issue. And all other kinds of things kind of become potentially tricky issues, right, as to what we want to do. So first, let's take a quick look at adding in that point and getting it so that it's going to hover around here, that we can instance another object to, okay? So I want us to look at both ways so that we have a firm understanding of when to make which choice and why. Now, I do a lot of polygonal modeling and I do a lot of NURB modeling, and they both have their benefits and their drawbacks. NURBs, I think, are, at first, I think most people are uncomfortable using NURBs, but usually when I show them how that we can use and harness the power of them, and Houdini has the unique ability that if you approach this correctly, you can go back and forth between the two, and this is quite powerful. I haven't found another application that can seamlessly do this, anything along the lines of Houdini, and going back and forth. And we definitely do get some benefits that you'll see very shortly when we look at NURBs, okay? So with that, let's just add in our add SOP, right? So I'm gonna make an add SOP, which is the way that we add in a single point or a number of points into space. We'll be looking at this in the next lesson. And extensively looking at this in the next lesson. And so if I just click that blue, we don't have anything created. I'm going to come back here to a single view and create one point by just making one point. It's there. I'll turn that on so we can see it. It's right there. And the idea is I'm going to want it to kind of come down Z, right, at the same place that it'll always be there on the radius edge of the circle. So we know that because we have that radius here. And as long as, we could grab any of these radius information, but we can also just never ever touch this and use the uniform scale, right? And so we know that that's a radius of 1. So I'm going to copy that parameter, and by just right-clicking, copy parameter, right? And come over to my add SOP, and then here in my Z section, I'm just going to come here and go paste relative reference like that. And you can see our point has just kind of shot right up there because it's radius and not distance. And so now if we make that bigger or smaller, our point is always there, right? No matter how many points we make it, it's always going to be in the right spot, etc., right? So let's just put that to 60. And then now what we need to do is we need it to be at the same height, or well, we need it to be lower by a certain amount, right? So we're just going to make another real simple arm, and that'll come off. And so I'm going to put this at 5 right now, and we'll and we will just come here and go copy parameter, and then here simply in Y we'll go paste relative reference, right? And now if I come to here, we can see that our point is sitting directly on there like that, right? Okay, so we want to push this down a little bit. And I'm not quite ready to start rolling this into a tool yet. I don't want to do that. So what I'll often do when I'm in this kind of exploratory stage is that I will just come here. I'm going to make a null. And I'm going to color it black. And I'm going to call it capital Control. You can call it whatever you want, but this just lets me know that this is going to be a node that's used for controlling attributes until we roll this into a tool, right? So it kind of allows for a little bit easier of playing around with. So with our null selected, I'm going to come up to this gear menu and go Edit Parameter Interface. And I simply right now, I want a float value, right? A slider that we can adjust back and forth that will act as something to subtract that, right? So I'm going to hit that, and let's call it right now, call it arm height adjust or something like that, right? Whoops, I hate, whoops, didn't mean to do that. Arm height adjust. And I'll copy that and paste that into here. I don't use underscores often. I try to use camel case or whatever this is called here, where the first one's capitalized. That's just because Unreal does it that way too. Unity with C#, usually that'll be lowercase, but I try to come up again with a convention that I use. And here, what we can do is we can just set a range for now. We can set it from 1 to 10 is fine. Let's lock it at 0 and hit apply and accept. And now we have a parameter that we can copy and subtract in here, right? And so this is just a dumb little hack. What I usually do is have an empty transform lying around. Because we can't just paste relative reference in there. So I will come to the control, copy parameter, come over here, paste it anywhere, paste relative reference, right? And then we can just kind of grab that, copy it, and then in here in the Y, right? In the Y, I'm going to come here and just minus that like that. And now we didn't make any amount yet, so I would have to adjust it, but there we go. We can adjust it, right? Okay, so I'm going to leave this around just in case we want to paste anything else in there. For now, we'll delete it momentarily. So now what I want to do is I want to use this. And in this particular case, let's just do something like, just for quickness sake, I'm going to make a tube, right? Our tube, right? And I want it to have some end caps, and I want it to be going down the z-axis, right? And we want it to be going down the z-axis because that's what Houdini uses at all times to copy objects to its points. But we're going to go over this a couple of different times throughout these lessons because this is kind of an important thing, and we can show Houdini does a few things that are a little bit funny if you haven't provided any kind of normals. So let's first look at it, what happens when we don't provide normals, right? So I'm going to just make a copy to points by coming here and copy to points, right? Point goes in the left, the right rather, and that goes in the left, and it's worked correctly, right? It's copying it because it is always going to try to find it going down Z. But here, if we were to change this to Y and X, right, it's still working, but you will have to see this in a better example where you see where it doesn't work as well. Let's make sure that we just keep it down Z here for now. But I'm also going to make sure that we add in a normal, right? Because truthfully right now, we don't really have a point normal, and Houdini is making some assumptions. And in this particular case, it's working out for us, right? But we're not actually giving it a normal, and I find that to be a bad habit, right? So we can add normals with, there's a variety of ways. In this particular way, the fastest way is to basically write a wrangle. I'll show where this will not work for us later on, but for now, let's just assume that we should always be supplying normals to our copy to points, and for that, we'll use an attribute wrangle. We can just drop it in there like this, and it's the simplest code in the world, right? We can just do A at capital N for normals and P, they're capitalized at all times, equals curly braces, right? And then we just can define our normals. So we don't want any normals down X, right? We don't want any normals down Y, and we want a normal down Z, and we end it with a semicolon like that. And now you can see that a normal has been added, right? And that's what we want, right? And so there we go, like that. Now we have an additional problem, though, is that if we don't make any adjustment here, then it's we have the potential of it intersecting our surface, right? So let's get the whole thing going here. So I'll template that, and let's take a look at what's going on here. And you can see that's something that we definitely don't want, right? So we also need to subtract it by the radius here, right? So we need to also do that. So what we can do is we can just simply copy this, right? And again, what I'm going to do is I'm just going to paste that into my transform that's not doing anything so that I can copy that, right? So let's copy that. And let's come back to our add SOP, right? And I'm going to insert this here first. So we're going to minus it, that, right? And we want to plus that, because remember, two minuses make a plus, right? So it's a little weird. It takes some getting used to. Let me open up this expression so that we can talk about it a little tiny bit, right? So what we're doing here is we're referencing our polyextrude, the distance, that's the length, right? Then we're simply minusing it by that radius scale, right? So if I was to come back here, let's look at this control and put in 0, and then actually maybe this does need to be a minus again. Let's see, because that should be at 0. That shouldn't be added. Oh, you know what we have to do? This is what we have to do. We have to do this. So we're going to have to wrap this up a little bit different. So I'm going to just open this all the way because we need to multiply that radius by 2 because we only want half of it, right? So here's our first radius thing here. So I'm going to, let's open this in the Alt-E like this. It's just a little bit easier to read, right? And I can separate this out a little tiny bit, right? So while I'm typing it, right? And I'm going to wrap this in another parentheses. So I'm going to put a parentheses there, and then I'm going to multiply that by 0.5 and add another parentheses like that. And I want to make sure that this is working perfectly. So I'm going to come here and I'm going to copy that out like that and hit apply. And now we should see that it's sitting perfectly, perfectly on top of the top, right? Like that, we can see that. So if I came into the side view, right, it's perfectly sitting at the top of that. And then I can add back in that adjustment, right? So just paste that back in here, and come over here like that. Boom. And now we have it working correctly. So I could come here to the control and I can, look, we can hyperextend it, I mean, that is one of the problems with what we're doing. When we look at the other way now, you can see that actually we can prevent that from happening. Okay, so we have one other small thing that we need to fix here, which is no big deal. That it's just that we're copying it from the center, and that's not what we want, right? We want to copy it on the edge and maybe minus it a little tiny bit, right? Because if we start making this tube longer, you can see we're going to eventually run into some problems there, right? This is easy to solve. So what I'm going to do is I'm going to come here to the top view, right? And after the tube, I'm going to make a transform like that. And I'm simply just going to come up here and in here type in -$C min like that. And that way, now, if we look, and we copy it to there, we're getting it right on the edge. That causes some other problems because we probably want to push it in a little tiny bit, right? And so that we could build a parameter for that. But for right now, I'm going to do -$Z min plus 0.01 up. No, it's going to be a minus again, minus 0.2 or something like that. That's fine for right now. It's obviously not perfect. But we have something that's working, right? So I could merge these two together like this. I could copy this whole thing here like this. Right. We could do our final cleanup down here if we wanted to, right? So coming here, I would just do a group delete. I'm going to put in my wildcard for delete all the groups. And then I'm going to come here and add in a normal like this. We could just simply, because we've got this edge bev 1 here, and it's gonna work for this shape as well as this shape, and because we proceduralized it with that star, we could also just pull this up here, right, and grab those like that and copy those into there, and we're gonna get our bevels automatically, right? So this is an approach, and this all works. There's some drawbacks to it that we don't even really know 100% about, but we do have some basic controls, right? I can, I could come in here and I could start, making this taller, making this bigger, making this wider, making this taller. We could round off this top edge if we wanted to. There's all kinds of things that we could do that would make this a better model than it currently is, right? But we're also, somewhat limited in certain kinds of ways. So what I want to look at right now is how we could build this exact same thing, but instead of using polygons, we could use NURBS, and we can get some very, very tight control. One thing I just realized here, what we should do is on this circle, we should copy this divisions here, copy parameter, and so that it would paste onto the tube, right? So it's like that, paste relative reference. If you wanted to make sure that the tessellation would match, right? So something that's kind of nice to do. I mean, it's not going to match line for line here, but the equal amounts and equal amounts. And so let's, I'm just going to keep this lying around because we can use it, and I'm going to save this file, and then I'm going to save this file, and then I'm going to come back. I'm going to show one quick thing, and then we're going to jump into looking at how we would make this exact same thing in NURBS and how we would potentially get a few more benefits from that. Okay, so before we get started, back in Houdini with modeling, I want to kind of just take a really quick discussion and talk about kind of pipeline development, project development, etc. So I use a project structure that I've been using for a long time, and this is what I will be uploading into that you'd be able to access. And in here, I've created a folder that's just called Procedural Modeling. And if I double click on it, it has a numbered set of folders, and which makes it kind of really easy to script if you're working in a shell. And we probably don't need a lot of these for this course, right? But I find it generally pretty good for my project management to have something like this. So we have shared assets, which is where we can put in reference and 3D models, etc. And master footage, stitch media, because I do sometimes have to deal with VR, virtual reality types of stuff, edit for editing, project files, which is all of our stuff. It's already got folders and folder structures for everything. So if we look in the Maya section, we'll have your standard Maya project. And if you look in Houdini, I have my standard. And there's some there that I don't really use so much anymore, like DMAP or OTL. We could probably just change that right now to HDA. You can see how long I've been using Houdini. That's called OTL. And render and source images. Now, this is a personal preference. You can do it however you want, but I like to store my HIP files relative to my project directory. So I put all my HIP files within here, and then I access everything with a $job variable, right? So let's set that up. So back in Houdini, what we want to do is, I haven't even saved my project yet, so let's save our project first. So save, right? And I'm going to just navigate to my project, which is here, tutorials, procedural modeling, right? I'm going to come into my project files here. Let's just do it by name. Project files, Houdini, HIP. I'm going to call this procedural modeling 01, and get it named correctly. I'll just copy and paste that, hit accept, paste that into there, version it, and call it 01. And then I'm going to come up here to my alias and variables. So edit alias and variables, and I'm going to just set my job variable, right? Here, job right there. So what we can do is we can just copy the root project structure, which is here, right before HIP. So that's it. That's the path to our project structure. And then I'm going to just paste that there. That way, it's going to make it easier when we want to access files, or if we want to write out BGO files, right? Because I can just simply come in here, create a file node, right? And not the best way of writing out, actually, let's not even do it that way. Let's do it with a ROP correctly, right? So ROP geometry output. And I already have mine set up. So if we hit the P key, you can see that I've got a variable already. And what it's going to do, it's set up for kind of common uses. So it's $job, which is what we just set. So if I middle click, you can see, right? Middle click, you can go back and forth. So middle click, we can see there is our Houdini, and it's going to put it into a folder called BGEO. Here I'm using $OS, which is the same thing as operator name, op name. It'll do the same thing, but this global variable doesn't work with every node, and sometimes you have to do op name. And I don't need this to go in its own folder per se, but what I am going to do is I'm going to call this lesson 01, so it'll go in that folder, right? And I don't need it to have a frame number, so we can get rid of that $F like that. So it would look something like this: $job, BGEO, this folder called lesson 01, and $os.bgeo. And I could call this poly model example, and I could version it V001 and hit save to disk. And if I look, it will automatically be there, right? There it is. and it's created that folder for us, lesson 01. So setting up your environment here with alias and variables and setting up your job variable is very important. I'll be honest, I teach a lot of people Houdini, and this is something that I stress over and over in my classes. And usually they'll think, oh, I don't really need to do that, and then, you know, usually by the 6th week, they'll all be doing it because they'll see what happens when you don't do that and where things are potentially lying around in odd places where you don't know where they are. Plus, you get the automatic saving. So, and we'll talk about how we can proceduralize this later too. Okay, so with that said, let's get started and let's take a look at making the same kind of thing, but we're going to use NURBS, and we're going to use NURBS, and we're going to see what the kind of fundamental differences of those things are. I actually want it to be exactly the same pretty much. So I'm going to come here, and we have this uniform scale on our radius, right? Here, and so what I'm going to do is I'm going to actually proceduralize that. So I can come here, and again I can come up here to edit parameter interface, and I'm going to add a thing called radius scale, just so it's named exactly the same. We call it rad scale up here, and radius scale down here with a space, and give it a range of 0 to 1. And I'm going to make sure that we have a default value of 1. So over here in channels, I can put that in right here. So instead of 0, it'll be 1. Just in this tab menu up here, I'm going to set that default value and hit apply and accept. There it goes. And now we have this radius scale. So I can copy that and come up here, and I can put that here, paste relative reference. So it's been taken over, and now we can, you know, do what we want, or whatever, right? And we've got this procedural thing. But the reason that I want to do that is because I'm going to literally just copy this circle like this, right? Oops, by alt dragging, copy the circle, and we have another circle, and it has 60 divisions, and it's of primitive type polygon, right? So, but I'm going to change that, and I'm going to change that to NURBS. It's still got 60 divisions, and it's order 4, right? And let's talk about what that actually means, right? So we can actually talk about it a little bit easier sometimes with making a good little lesson here. So let's actually, because it is kind of an important thing to do, right? So let's make a adsop. I'm just going to quickly make, I'm going to come to the plan view. We're going to get into how we can use and really harness the power of the adsop for procedural curve generation. And things that we can do with it in order to make certain kind of shapes. And I can show some of the tools that I've built in the past, because we can do a lot with this adsop that we can't really easily replicate procedurally with creating curves, right? In this particular case, I'm going to just make 3 points for now, right? So 3 points, turn on my point display, and I'm just going to leave that first point is 0, 0, 0. The next point, I'm going to come up 1 unit in Z, and I'm going to come up 1 unit in Z and over in X like that. And so we have 3 points, and if I come to this polygonal tab, I can come into by group, and I'll get this polygonal line, right? We can see, there it is, right? So kind of what we would expect. So let's add a convert. And I'm going to, I don't generally use level of detail, so I'm going to use divisions per span. I'll just leave it at its defaults right for now, and I'm going to convert it from all types is fine, and I'm going to convert this to a NURBS curve. And we can see what's happened, right? So we get a smooth interpolation between the hulls, right? That exists here. and this exists here. And the degree type is 4. It should really be 3, right? So if I hit 3, you'll see that now we're getting correct interpolation. Why are we saying 3 and not 4? Well, we really only have 3 points, right? 1, 2, 3. This is what we call cubic interpolation, right? So if you ever kind of wondered what cubic interpolation is as far as a curve goes, that's it right there, right? When we hit it at 4, it's getting converted to a 4, but you can see we've kind of lost control of the curve, right? This CV and this CV were added, so we've got 1, 2, 3, and 4, but we've only got 3 points that are defining that, right? So if I come back to the convert and I put it at 3, that is equal to that, right? Well, we have another actual option too, is that we could set it to 2, like that. And now this and this are exactly the same, except for that this is a NURBS and this is a poly, right? And we can do the same thing with a circle, right? So what's happening here is that if I come and look at the top view, because this is a mathematically defined shape, a NURBS circle, and because we're on degree 4, that we're getting interpolation from the points that are being provided, and we're smoothing it. So, but this original circle is no longer sitting on the exact same points that we have coming in, and that can present us some problems as well. But it's also hard for us to kind of predict what the results will be in the end, right? So that's one thing. Let's come back and let's just look at one more example with our NURBS. So again, I'm going to come into the 2 thing, and I'm going to add a 4th point here, right? So 4 points now, and you can see it closes it, but I just need it right over there. So it's just 1 over nx like that. And now, if I convert it to a 3, right, you can see we're getting the kind of interpolation that we're getting, but the correct, we could do a 4, and it changes it. Because what's happening now is that now we're getting, in case you wanted to know, this is what's called quadratic interpolation, right? So linear interpolation, 2 points, cubic interpolation, and quadratic interpolation, right? And so between those things, we're altering the shape of our NURBS. But we really don't need to do that, right? Really what we want is we want this to be type 2, right? We want it to be a linear NURBS curve. So we get all the benefits of it being a NURBS, but we're able to kind of control the parameterization of it and the tessellation of it so that when we convert it to a poly, we're going to get the exact same amount of points that we would potentially have in whatever poly circle that we have, right? So let's look at the difference here. So let's proceduralize the next thing. So this is height, right? So this is distance, here is height. So let's add that into control here. So just coming under here, under control, I'm going to edit the parameter interface, right? I'm going to add a float, and I'm going to call it here under the parameter, just main height, right? Main height. I'm going to give it a range from 0 to 20. Now, we don't ever really want it to be 0, right? So what we could do is we could just type in a very small number like 0, 1, and then lock it so that they can, this is something that I'll often do because this is something that can break tools, right, potentially. And the other thing I want to do is I want to give it a default value that's similar to what we have here, which is 5, right, 5. So here, I'm going to give it a default value of 5 like that and hit apply and accept. And now we can use this to define our height. Whoops, that's weird. Something didn't work right. Let's adjust that. I'm going to come back to my edit parameter interface, main height. I didn't get that in there, right? Boom, apply and accept. And now we've got that main height here with a default value. So right click, copy parameter, and we would want to add that in here, right? Paste relative reference like that, boom, right? Boom. Okay, so we want to do the same thing here. So, but we're going to do it a little bit differently. We're going to add a transform. And here in the translate y, we're going to paste that same relative reference, right? There it goes. Boom. And here's our NURBS. Here's our transform. And now we could merge these together. We're going to have the same problem with the reversing. You'll see. I'll end up reversing that, I'm sure. And now we've got two NURBS curves, right? And in order to join those in Houdini, we use skin. For people that are coming from Maya, this would be loft or generally loft. We could hit the tab key and we type in skin. And we get the exact same thing. It's reversed, right? You can see that. So let's just come here and add in a null here. And let's reverse that here. Like that. Okay. Yeah, better. Okay. So there's a few benefits that I want to look at that we already have, which is one is that, and it'll also help us illustrate another thing here, and which is that we can get automatic UVs for free, right? So if I hit tab and type in UV texture, I can get, if I'm set it to rows and columns, I'm going to have my UVs now for free, right? No matter what I do. Usually fixed boundary seam should be on, and I'm not seeing any weird boundary issues. Sometimes we'll get some boundary issues, and I'll show how we can fix that. And sometimes it's maybe just better to do anyways, right? But if I hit the spacebar 5, we'll see our UVs, our UV map, right? And we could just come in here if we wanted, we could scale these up or down, and we can measure these to get them accurate, and we get our UVs for free. And they're contiguous, which is nice, because what would happen is when this edge, because they're going from 0 to 1 along this Y edge like that, this edge and this edge perfectly line up. And if you have a a texture where it's tileable, then that seam will always be perfect. So that's a huge benefit. I mean, in here, we would have to come in here and do some manual intervention for that to work, right? There are some things that we can look at procedurally with trying to grab a seam and using a UV flatten, but that doesn't always work. Okay, so let's go back, and because we want to build this kind of basically this exact same thing. And then I'm going to show some of the extra benefits that we get, right? So one, if we, this one is hollow up there, right? Yeah, see, so if we look inside here, it's going to be a perfectly hollow watertight object. See, there we go. You can see in here, it's hollow, right? And so we want the exact same thing as that, right? So we can do that. And we can do it in a variety of ways, and there's benefits to doing it in multiple ways, right? So let's look at our skin. And one way that we could do it conceptually, right, is that I could just come here and I could add a transform. And I want this transform to be exactly in the middle. So if I look, it's going to be down here. So we got to proceduralize our pivot point, so wherever it is. So that's easy enough to do. Over here in the pivot translate, we just enter in our global variables for $CEX, $CEY, and $CEC. We really only need to set Y in this case, but whatever, for whatever good reason, it's good practice to do it that way. And now, if I was to scale this, right, we get the same conceptual thing, right, as we do there. But look what's happening. We're getting that smooth interpolation through the holes, right? And that's because that on our skin, we have it as a degree 4, right? But we can come here and we could set it to degree 2. And there you can see we have our underside, right? So we could kind of quickly mock this up, right? So like I would go like this, right? This one I'm not scaling, right? So it's the same scale, but I'm moving it up like by 0.1 or whatever, right? It's kind of cool because you could just keep dropping those in, right? We could make it exactly equal, whatever that is, right? So here the inset. So here is the inset is minus 9.1 when we need it to be bigger. So that might be, we would have to do it. That'd be a little bit actually tricky. But here we could grab this distance one at least for now. So here I'll just paste relative reference, and we could just add it in this. Sometimes that happens. And now we have that exactly the same, right? And here, if I'm scaling it 1.5, then, and truthfully, we don't even need to know, we just need this curve moved up. So that's this, let's see, so here to here, right? We're expanding it. So that's this curve. So I could actually just grab a null conceptually. And this would be, it has to be equal to this one, right? The same thing, the height. So we just move that up to here, like that. And now we do that. Let's take a look so we can just avoid any confusion as to what's going on here real quick and do a quick breakdown, right? Because we can see that this is starting to work. And look, if we look, you know, our UVs, we still have them, but we run into some problems here as well, like that. I'm just going to do a little tiny bit of cleanup so we can take a look. So we've got our original curve, right? This at the world, 0. And then we move that curve up. We can template that. Then, and we can even do this. Look, so we can look at it one by one, right? And here's our skin. So we have this curve. We add it into our skin, we get a tube. We scale that curve, we get a tube with a lip. We move this same curve that made the lip up, and we get our extrusion. And then we need this curve again, because it's going to be the same size as this. We know that. It's just down here. So we need to kind of branch off and raise it the same amount as this, right? And then we get that and that. And now we could grab that extra extrusion that's coming off of here, at the highest one here. I'm going to copy that, copy parameter. And I'm just going to grab this. I need a transform off that curve. So it would come from here, right? And but I don't want this. I want it to be the other one. So I changed I copied it. It's coming from this extrude now here, this distance. So copy parameter. And here, paste relative reference. And then if we put that in here, right? We now have our skin. It's exactly the same. And we can UV texture that, and I can merge that and that. And now we have essentially the same kind of thing that's here, right? With some benefits that we're going to look at. Now, I would personally probably break this out and do this as a separate skin, and which we're going to ultimately do. in the next lesson. But at first, let's take a look at some of the advantages that we now have, right? So besides, we get the UVs for free. They're not perfect UVs, but there's ways of making them much better. And we just need to UV that top. And in order to UV the top, what I'm going to actually convert it. And we're going to convert back to polygons now, because that's actually what we end up wanting. I'm going to do this one first. And the reason that I'm going to do this one is that I want to show something, right? So here we have level of detail. And if I come in the top view and hit spacebar G and hit the W key, right? Like, it's basically looking at the level of detail of the object and then tessellating it based off of that. And what I usually like to do is I like to kind of control the tessellation. And in this particular example, I want it to exactly equal that, this, exactly equal the circles that come in, and so that we can control our tessellation up here and know that it's going to be accurate, right? So the way that we do that is on the convert node, we use divisions per span like that. And we just set it to 0 and 0. And now we're going to get the exact same. It's going to have 60 across, just like that. And we can come up here to our circle and we can control our resolution of our object like this, right? So that's that. That's all said and good, right? Here, after this convert, so I'm just going to smooth wire shaded and turn off the display of the UVs, we would add a fuse to make sure that we fuse these points, because they're not going to be fused, because this is a separate object and we're just merging it together. And oh, let's give that a UV unwrap too up here. So let me just turn back on the UVs. Remember, we didn't add any UVs up there. So just UV unwrap, right? Let's just take out any of the spacing. That just makes sure that we don't have any spaces around it. So like if I look here, right, if you have spacing, it just does that. We don't need that. And then we can fuse it together like that. And now we should just be able to copy all this, right? So copy all this. And we're going to get the exact same thing, right? Boom. Perfect. Okay. Pretty cool. Much better, right? So what we've learned now is that we've learned how that we can kind of control our objects through NURBS, and we have the same level of control. Let's move this one over. Like, I'm going to just transform it over. Let's just transform it over like there. And let's display this one, because we're to here right now. Look, it didn't grab the poly bevel on that. That might be because, let's see, why did it not do that? Oh, I need to convert it to, got to convert that to a polygon. Otherwise, nothing, that won't work. There we go. Now we have our bevels correct. That's just because I didn't add a convert there, but it's all working now. Okay, so we have that object and that object. Let's do a space bar H, right? And we have our controls here, and we can now adjust the main height, right? We can adjust the radius scale, and everything is working together and in tandem, right? We haven't built that arm yet, but let's look at why we haven't built that arm yet. And let's look at some of the benefits right now of doing some actual NURB modeling, right? So like, let's say if I wanted to put bolts here, how would we do that? How would we do that with the polygonal object? Well, with the NURBS, it becomes quite simple, right? And this might be where we start to want to separate it out, but before we do that, let's just add in a carve. So a carve like that. And if I hit carve carve is going to allow us to carve up NURBS. It's got to come there. There we go. After the NURBS. So it's going to allow me to procedurally carve up this NURBS object, right? And we can carve in the X and the U, so you can see what I'm doing there, right? Doing that, right? That's working. And in this particular case, though, let's do the first U, and I'm going to come up here, and you can see what I'm doing, right? And instead of setting it to cut, I'm going to do extract. And I'm actually getting only one curve right now. So it's, they have these. So if we just put a null in, we'll be able to see it more clearly, right? So there it is. The carve, when it's on, it's allowing you to see a bunch of different things to give you an idea of where you are, right? So if we come, I'm going to template my convert there, right? And I'm going to look at that carve, and you can see we're moving this line, and we're getting a curve that's kind of like perfectly up there, right? And now with that curve isolated here, boom, right? We can look at the number of points. So we've got, so we have 60 points, right? Or 68 points, because I adjusted it, whatever we have up here, right? So 60, like that. Oh, we can't control it there. Oh, we can actually. These should be equal. Let's just make sure that they're equal. So copy parameter. I could put it on that control to paste relative reference. And let's not template that and template that. Okay. So now we've got a curve that we can use to add, you know, bolts that are conceptually up there. So let's do that. Let's bring our carve down, right? And let's just come here. Let's make a tube, another tube, right? Our conceptual bolt here, we will give it 6 sides. It's a hex bolt. It is 0.1, 1, 0.2, and 0.1. And we have our little like nut type of character. We're going to want it on the Z axis, and we can just steal this transform from over here. We could have just grabbed that actually. But here, I'm just going to do this because we've already got this made. And that's just going to make sure it snaps to the, except for that. Boom. And now we could do a copy to points. And already you can see that we have a little bit of a problem, and it's not copying correctly. Now, this is where we're going to see what I was talking about. Like if I put that to y-axis, they're going to copy correctly. But we're actually really not in control of our world here. And that's really not what we want, right? Because Houdini orients things down Z for copying. And so we always want our copies to be down Z. The problem here is that we have these points and we don't have any normals on them. And it should really be polygons. So the first thing let's do is let's add a convert. Right? Convert it from a NURBS to a poly. Again, we don't want level of detail. We want divisions per span to be 0 and 0. So now it matches exactly for, right? And now at least it's kind of approximating some point normals for us, right? But we should still add them. So let's add that wrangle, right? We want to have them. We don't want Houdini assuming what we want, right? Plus, we can't do anything with them. One of the things that's a little bit confusing too about Houdini is look at, you can see how if I convert and I display my point normals, it's showing like they're there. That's the assumption. They're not really there, right? And they're this kind of dark green color. So if we come here, we can now add in our expression at capital N, right, equals curly braces, come in here, none down X. We want them up on Y and none down Z. And then we just need our end colon, semicolon. Okay, so now you can see we've added our normals, we added our, sorry, we didn't mean to quite do that so fast. And let me untemplate it. We added our normals, they're turned green now, right? They're not just that, I mean, they turn that cyan color. They're not just that weird green, and we're copying to our points, and it's correct. So one thing that we'd want to do is probably have a resample in here. So this is way too many bolts. And so we can add a resample in here, and we can resample it by maximum segments. So we can get like there's 10 bolts. All right. We can change the size of our bolts, and we could merge those. Back. Let's see, I'm going to do it. I'm going to do it here. Excuse me, I'm going to do it actually here. Okay. We can also control where those sit, right? So, we can come in or out like that. We can control the size here, right? So we have kind of we can control the amount. So this brings up another issue, which I think is good for us to look at. It'll be the kind of the last thing that we look at in this lesson. We're going to add the arm in the next lesson and stuff like that. Which is that these are all just kind of a little bit too perfect. Maybe we want some underneath there too, right? Well, for now, let's deal with this one. Okay, so let's add in a for each point. And we're just going to do it like that and get rid of that and come in here. Whoops. And come in here. We end up getting the exact same thing, but we're going through a for each. Well, why would we want to do that? Well, there's several different things. One, let's imagine that now we want to kind of make these so that they're not all rotated the same way. And we have this transform, and you can see if I start rotating them around the z-axis that they rotate, right? So what we can do is we can create an attribute randomize, right? Attribute randomize. Automatically we get color, which is not what we want. Oh, and actually, sorry, we don't want an attribute randomize. We want a attribute create. Right? And we're going to call this rotate z, like that. And we want to basically produce random values. I'm gonna actually produce integer values and I want random integer values between 0 and 360, right? So this is an expression that I find helpful a lot, and we're going to see how we can use it in other situations as well. But basically what we want to do is, in this particular case, we want to create random integer values between 0 and 360. So what I'm going to do is I'm going to write int rand $pt, which is each point, and then multiply it by 360, like that, right? And if we look now at the points here in the attribute create, in the geometry spreadsheet, you can see that we have a bunch of random rotational values, right? 230, 288, 183, 98, etc. And we can use those here because we're going to be running it through a for loop, right? And so I like to name my for eaches. So we could call this for each main bolts 1, just in case we ever have another one. And let's look at the end of our for each here, right? There it is. And here in the transform, right, in the P, I'm going to bring up, using P and bring up the parameters, we need to add our expression here, right? And that expression is just a point expression, point, right? Point expression. We need to find the node that we want, which is for each main bolts, right? End the quotations and add a comma. 0 for the point being operated on. It's always going to be 0, right? Rotate Z, like that. That's the name of the attribute, I believe. I always forget. I have to go back and check. And there we go. And now we can see we have random rotations where they're not all the same. Yeah, they're not all the same, but you can see they're no longer all pointing in, you know, towards the center of the world, right? So that's actually working. I want to show one other thing that that we can do here too, and we're going to look at this several times throughout the course. I use this all the time. On the for each main bolts, I'm going to create a meta import node like that, and I'm going to add in another wrangle, an attribute wrangle. And I want that to go into the first input like that, right? And I want that to go into the second input like that. And the for each meta node is going to basically give us access to certain kinds of things. And if we look at it, you can see it's going to give us these so if you just on the meta import node, you look at the detail attributes, it's going to give you these iterations, numerations, value, and I value, and we can use those. And I already have some Vex code. It's very simple, and in here I've got it saved here as a preset. And it's just real simple. It's basically just saying create an integer and create an attribute called ID that is equal to that concept of iteration. And if we look here, what we're going to get here in the geometry spreadsheet is if we look under detail, if we look here under, it's a point attribute because we're running it over points, that you can see we're going to get a unique ID per object, not per point. We don't want it to be per point, but it is a point attribute, right? So all of these points are existing in copy 1, all these are existing in copy 2. So we could get groupings out of this. In this particular case, we're just ending up with this ID attribute, and that would allow me to make another wrangle, right? So let's make another wrangle here at the end, right? And this wrangle also, I have some code here this code here, let's just look at it again, right? Here it is, int ID is equal to detail, then, 1, comma, iteration, comma, 0, and then I is at ID is equal to ID. And then here in this one, I'm going to, I have a preset to create ID ramp. It's real small as well. I just need to change this to be this. So here what we have is we basically have float R, right? R, it's just a float value, is equal to random at the ID seed ramp color. And this is basically creating a seed for us, right? And then we basically want to take a vector and apply that to R, to that random ID color, right? We don't see anything yet. You can see what this code looks like. It's here. I'll leave it up for a moment so you can write that yourself, right? It's very simple. It's just basically making a color, a color based off of a vector, which is going to be based off of a ramp that's going to be created based off of the values that are coming from R, right? So if I click this now, it's going to make the interface for us because we're asking it to make these channels for us, right? So channel ramp and channel integer, right, for the seed. And so we can click that like that, and we'll get our ramp and our integer. And then you can see we have a seed, so we need to use that, right? So as soon as I click that in, you can see now that we're getting a random color distribution across our bolts, right? And we can use this in Unreal, we can use this for shading. It's a great way to kind of randomize the slight colors so that when you put textures on them, they don't all look so uniform. So we could change the color like, to a muted industrial green to a darker kind of rusty color, maybe like something like that, right? So something that we can do only if we copy and run things through a for loop. Let's add a color to this too, so we don't get that error message. I don't like getting error messages, so we'll just add a color. And we need to get rid of ID and rotate, and we need to add some UVs in here, right? Because these don't have UVs. So what I would do here is let's add in a UV unwrap here, right? So we'll add in a UV unwrap here. And then I'm going to just grab these actually and bring that off of here like this, right? And now we just have, when we're getting this is just a warning message, but it's basically saying there's some incoming attributes that are not the same. So remember we made these attributes called ID and rotate Z in order to be able to do these. We could add in a little bit of a p-scale attribute too with an attribute randomize. But this has those attributes, right? ID and rotate Z. This does not. We're getting an error message. So let's just do some cleanup, and let's just do that with an attribute delete, right? Attribute delete. I generally try to not have warnings. Sometimes they're inevitable, but I try to not have them. So I'm going to delete those two attributes with this attribute delete. They're point attributes, right? One of them is rotate and Z and ID, right? And now that error message has gone away. This has still there's a group lying around here, right? Edge bev 3. We don't want that, so I'm going to group delete here like this. And in the group delete, I'm just going to add in a my wildcard like that. So now we have no groups. We've got UVs, we've got color, we've got position. The only thing, the color is just there. I'll change that to like a gray for now, right? Like that. And let's let's add in our normals, right? Normals. And that's fine for right now. Okay, so that is a fully complete object in the sense that, I mean, we're going to do more work to this to continue talking about some of the foundations of procedural modeling and looking at more things like, one, how we can add that arm. But we can already see that, you know, the ability to easily place objects along here are much easier than when we have NURBS than we are when we have polys. And we can add in a lot of different levels of controls into how we add in these objects. And you'll see as we start doing it, we can add in noise, we'll enhance this, we'll add some washers, you know, we'll make this look more realistic, right? And it helps us because we can also add those wherever we want. We can add in straps. Like if I wanted to add a strap to this, it would be simply a matter of me making another carve, right? I would come off of here, right? Like this. And in this particular case, I'm going to just grab this null so I can see what the carve is leaving me with, right? So here on the carve, we want to extract a curve, right? I don't want that curve. Again, I want a U and a V curve. Let's grab that, and we can skin. We can actually, yeah. Let's grab both of those, but let's pull them down. Let's see. We want this to be here. Let's add a strap like, right? And actually, we don't even need to. We don't even need to extract. We can just cut, right? Yeah, like that. And now we could convert this here, right? See here. Let's just look at what I'm doing here. I'm going to untemplate that skin, right? So I've added a carve, and I'm just basically carving in the U, right? And we could make that thicker or thinner, right? And we're just left with this portion of the NURBS, right? We could actually add an additional carve if we wanted to. So now we could do a carve here. It's another carve, right? And this one, we want to do U and V. So I'm going to see like, okay, yeah, there we have some kind of metal thing that we're going to put on there. So I'm just going to convert that to polys, which we've done here. And then I'm going to add a poly extrude. Right. And let's I'm going to pull these out. I'm going to clean this up in a sec. We don't need these two nulls. They're just help me when I'm visualizing the carve. I'm going to take that out of there and put that into here and that into here. Look, we just have P for that for now, right? Okay, right? So now we have this ability to add in straps. We could, you know, like, I mean, I've carved it twice, right? So that could be on a switch if we wanted it, and we can proceduralize that completely. So it's, you know, I mean, we could make it where we could figure out how to make this into like a thing that would have a bolt that would go through it or something like that straps sometimes have. Whatever, but we've got quite a bit of control. Let's just add in for this for now. We'll add in a UV unwrap. and we will add in a color so that we have a color on it too, and we could color it like rusty or something like that. Okay. Not a bad little object. We'll be expanding upon it later. I'm going to add that switch UV layout to here so we can get our UVs nice and uniform if we want them. And then we come here. Right. I ended up moving it off to the side with that transform so that we could take a look at the two of them together. That's I put that. Where did I put it? Here. It's somewhere around here. Or maybe I moved the other one. I don't know. But we could pull it back in. Oh, I had it here. I guess it's not moved anymore. There we go. So anyway, so that's a fairly complete object. If we look, we've got all of the things that make a unique 3D object. Now, we might want to have some groupings, right? And you've noticed that I have this thing here, group delete, and I've grouped everything at the end. And I did that kind of on purpose because I do want to talk a little bit about something here, right? So we have groups, and groups are great. I use them all the time when I'm procedurally modeling. But in the end, I get rid of them. And what I end up using is what's called name, right? And if I make an attribute create, right, what I want to do is I want to set it to string, right? So, and type primitive, and set it to string. And let's call this one bolts. Okay, here we'll call this one. So I'm just going to copy this, and we can actually do the same thing. You know, we can. Now I don't want to do that. In the attribute create, I'm going to keep it bolts like that. I'm going to copy this attribute create here, and I'm going to call this one strap. And I'm going to copy this one, and I am going to call that one main support. Main support or something like that. And now if we look, oh, whoops. I forgot to give it the actual attribute name on each of those. No good here, right? So here under name, the attribute's got to be called name. And here under attribute name, same thing. And here we got to have attribute name. And now if I was to have that attribute called name, we have something that basically functions just like groups. There's a few small differences between them. If I make a material node though, right, I can make 3 materials, let's say. And on the first material, I would want to assign it to bolts, right? It's slightly different. You get this at name equals bolts, right? And main support here and strap here. Now, obviously, I'm not making any materials for it yet, but you can see that we can assign and delete, right? We can do the same thing like we can do with groups. So like here, I could append a delete, and I could delete out the bolts, and they'd be gone. So we can use this attribute name a lot like we can do with groups, but then the question is, why use name over groups? Well, there's a few different reasons. One, name is going to play very, very well with Alembic and USD. That's number one. Number two is that name has a little bit more, well, basically what I want to say is that with groups, we can have a problem, right? We could have this called boots, this called strap, this called main support. And then those groups could exist in another group called pull or something like that. Now, that conceptually, if you think about it, has some problems to it, right? And especially when it comes to kind of this concept of efficiency and namespace. And the other thing is this attribute name is something that we use a lot in Houdini because it's kind of more easily exposed to us. But this concept of name exists everywhere, right? So it exists in packing FBXs or Alembics or USD files, or how certain things are translated over across platforms, right? But let's take a really quick look at something here, which is what I'm going to do is I'm going to make a copy to points. I'm sorry, I'm just going to make a, yeah, let's do a copy to points. Let's just scatter. I'm going to make a grid, right? I'll make that grid quite large. Let's make it a 100 by 100, and we want it on the ZX plane, right? So that it's on the ground, and let's just scatter 100 points or whatever. It doesn't really matter, to tell you the truth. We can do a attribute randomize. And I'm going to attribute randomize the attribute. I'm not going to do color. I'm going to do p-scale, which will change the scale of our object. And I'm going to do from like 0.5 to 1.5. We only need it to be one-dimensional, right? P-scale is a Houdini attribute for scaling objects, if you didn't know that. So when we want to randomly scale things, we can do that really easily with this attribute called p-scale. Houdini will recognize that. We don't need to write a point expression for that, right? So, but let's do a copy to points. And I'm going to do this in a for loop because in the next lesson you'll see why. It's mostly just to enforce the idea that we should be working often in a for loop and to not have us be scared of for loops. And so the points are going to come in here, right? The points are the copy. Here we go. Whoops. And from the material out. Whoops. Oh, whoops, I did this completely wrong. Not there, but there. And here. And now we have all of our objects randomly copied to our points, right? Whatever, fine. I don't even care that they're interpenetrating or anything along those kind of lines for this, right? Now, if we were to come to this copy to points and we were to pack an instance, right? We are now instancing. We're correctly instancing, right? And you can see if there's a piece attribute, it's called name, and name is not, so ignoring piece attribute because it's not, so that's weird. Hold on, let's see. Name there, it's a primitive attribute. This is actually what we want, right? I don't know why, because we don't actually have pieces or anything like that. And we're not separating things through name. But basically what ends up happening is that we now no longer have access to this geometry. And we've packed it, which is good. We want to be packing, but we're also packing 1,000 pieces of geometry. And they are instances, right? But if we were to take this into Solaris, right? So like if I have a null here, and let's just take a look at this. I'm just going to call this instance out like this. I usually like to color those black. And I'm going to open up I'm going to do that. I'm going to come up and come into Solaris stage, right? Stage. I'm going to set my desktop to a Solaris desktop. It's just the same as the Houdini one. So if you were to do that, you would get a Houdini Solaris stage, right? Because we want to take a look at what's going on in here, right? And so I'm going to save before I do this, just in case. And we can just call this poll, right? And here we want to be, we're in Solaris. We're not actually importing this into Solaris, just so that we're very clear. This is not in Solaris, it's in the object. You can see here, OBJ, right? So we have to import this information into SOPs, right? So let's have a SOP import like that. And what I can do is I can just dive in here and add in my SOP path, right? And here we go. So now we're in Solaris land, and we have our object, and it's pretty fast and pretty fast and responsive, right? And let's just click open though our SOP import, and now you can see that. Look at all of these objects, right? There's going to be 700. Or in this case, 1,000 of them. I didn't even adjust the number on the scatter, right? And while we have good memory geometry footprint, you can see our memory space has gone down to 1.54 kilobytes. We've created this kind of spreadsheet nightmare a little tiny bit, right? And for not that much, for what reason? Because we might want to come in and have a different material on that strap. Now, we can control that in much better ways with attributes, right? We're basically, what we want to do really to be efficient is that we want to be able to pass in all of our attributes on bolts, one bolt, so that we can apply a bolt material to one object, and that attribute, whether it's variety of color or whatnot, can be done correctly with just a small footprint, right? And what's happening here is that because we're just brute force the instancing, right? We're getting an instance per copy, right? And we're getting instancing, but we're getting a hierarchy per copy. So I usually try to avoid that, because when you have scenes that potentially have a million different instances, it just takes so much time to instantiate in the spreadsheet this a million times, and it can crash your machine. It won't be the geometry that's actually causing the problem. It'll be writing out this hierarchy, and this will also come through to Maya, which it'll bring it to a crawl. Or just crash, We can look at that and see how we can never ever load this nicely up into Maya. And it's loading into Solaris. It's not a great way, and if we had more, it would really bog down or crash. So let's just turn off the instancing. I'm going to come back here and turn that off. So I don't want to look at that for a sec so we don't crash, right? So I'm just going to do a SOP import and do it like that for a split second, right? And I'm going to turn off instancing, pack an instance, right? And now, right, we have 4,253 polygons, but we have this name attribute, and we have our objects separated. So what we could do is we could add a pack node here. And this would actually allow us to also perform some operations in here if we needed to, right? And we will do this in the next lesson. I'll add in, this and this ramp so that we can give these a variety of color, and then we can pack it after that. This way, we would have to, if we were to instance it here and pack, we would then have to unpack it, add it, and then pack it back up, and then we would still be stuck with the problem that we'll have this crazy hierarchy over here that's going to create 999 different things in the spreadsheet. But here, what we can do is we can pack it, right? And we can give it a path, give it a name, and then take it off of create packed fragments, right? And now, once we've done that, and we can see that we're going to get the same memory footprint basically that we're getting from before. But if we come back to our SOP import now, and now we look, we're getting the same thing. It's very fast and responsive, right? But if we look here, now we only have bolts, main support, and strap, right? So we can apply materials to the, one object, bolts, main support, and straps, 3 different materials. We don't have that crazy structure, and we know that they're instanced because we have this prototype here, right? And we're getting all the instantiated, the instancing results from packing it this way, right? And look, we only have 3 packed geos, right? But they're still being instanced inside of themselves because they're the same piece of geometry, because they're using this namespace. So, and if we were to bring this into Maya, which we'll look at later as an Alembic, we're going to be able to figure out how to get these as our pieces of geometry. If you look here on this SOP import now, right, and go geometry handling, right? Primitive definition here, right? What we could do is here, packed primitives, create native instances, path attribute, path and name, right? And the only thing that I don't like here is that we get this import path prefix here, which you can see here. It's SOP import, right? And that's coming from here because of this $OS, right? So we could give this a name here, right? Or we could give it a name here, right? However you want to do it. So this is just taking that operator string from here, but you could also just call this like support assembly, right? And now we have this master thing called support assembly, right? And now we could make a material library, right? Like this, right? And in the material library, you can see that we haven't added any materials yet. So let me just add 3 materials in really quick here, right? I'm going to add in this particular case, because I like to use Material X, and I like to use this Material X subnet. It allows for a little bit more control over certain things, right? And so we could I'm going to just make 3 of these. So we'll call this one bolts. And then before I make the other 2, I'm going to dive in here. And I'm going to get rid of this. This is just a basic surface. It's nothing. And I'm going to make a PBR, Material X PBR. And we want a standard surface like this. Right. Call that bolts, strap, main assembly, main support is what I meant to do, not assembly. Right. Now we would come back up here, and let's just pretend you can see we have our materials are here, right? So here we have this thing called support assembly. Here we have our world, right? Our world. We have support assembly, and then we have materials, right? And maybe I want materials to go with that support assembly, right? So we could just copy this from here, right? And we could do something like this. I usually just paste it there. And now we can see they're going to exist in the same container, right? Support assembly, here's the materials, here's our geometry. And now what we need to do is autofill those materials like that, right? There they are. And now we can assign those materials. like this, right? We need 3 material assignments, right? And so primitives, right? That's just going to be our primitives, right? So here under the pack, that's going to be bolts, main support, and strap. And then and here's our materials. So bolts, main support, and oh, whoops, I got one wrong here. This is main support. Look at what I did. I did it wrong. So this one would be strap is the materials, and strap is meant to go there, like that. Okay. Excuse me. Our color's gone away. I'm going to save here. And that's because USD doesn't use CD for color. It uses color display. But what we can do, and that's kind of one of the reasons why I built this, we want to be able to import our Houdini attributes, and we want to be able to share them and stuff like that. So we can make a primvar, USD primvar reader. I always forget exactly which one it is, right? But if I hit the P key, I think it's going to be, we need a vector, and it's going to be called, I think it's display, I think it's color. I always get this wrong, color display, or it's either color display or display color, right? And you can just pipe that in like this to each one of these. And then inside now, we would get our results. So we could put that into base color. And obviously it's not working. But I don't think I'm on Karma yet either, base color. And base color. And let's see. I might have to color display. Is it display color? It is. It's display. Let me try that. Color. All right, let's fire up Karma. Karma. There we go. So display color, and it's now working, and you can see how fast it's rendered, right? We're getting our instantiating. We could easily just come up here. I'm gonna just quickly, I'm going to come in here, right? We can mess around with this later. I'm gonna add in a camera, right? I'm going to add in a area light. I'll just look around at it like this, right? Come back to my perspective camera, right? And let's add in our Karma. That. Now we click on that, and now we're actually really rendering with Karma. Let's just grab this environment line, turn up the intensity. All right, not bad. I will expand on this in the next lesson, but you can see how basically, you know, that we can look at how we can kind of like pack things and create things within SOPs and bring that correctly into USD. We'll look at how we can expand upon that. But this was meant more as a, stage. I'm going to go back to the object context now and into our poll, is to begin to look at some procedural modeling techniques. We'll, let me just do a little bit of cleanup here. All right, we don't need this stuff. We've looked at the kind of like the fundamentals of NURBS. We're going to expand on that a little bit more and learn how we can build a variety of different kinds of shapes using these kinds of techniques. But this is just the beginning. We're going to color these all randomly. and we'll do a bunch of other things in the next lesson.